Hello Chem 100. This next section is about polyatomic ions. So far, we have been making ionic compounds with two elements. For example, if I wanted to make a compound with potassium and sulfur, potassium is right here. We know that potassium will become a +1 ion, and sulfur is over here. We know that this group has 6 outermost electrons and it wants 8, so it will become a -2 ion because it's 2 away from being like argon. And we know that this compound, in order to be neutral, a -2 and a +1 does not get us to neutral, but 2 positive ones would give me a +2 and 1 -2 would give me a balanced neutral compound. Again, we could also just crisscross sulfur's charge to potassium and then 1 sulfur because of the +1 charge of potassium. So this would be potassium sulfide. We also could make another compound. Sodium, also in that same +1 group. And nitrogen is over here, has 5 outermost electrons. It's 1, 2, 3 away from being like neon, so it becomes a -3 charge. And therefore this compound would be Na3N, sodium nitride. But for this, we are going to look at polyatomic ions. Poly means many, atomic means atoms. So many atoms together, that forms an ion. Here's a few examples. This plaster cast is called calcium sulfate, CaSO4. Notice that this has more than 2 elements in this compound. We have calcium, which forms a +2 charge, and if we look at calcium, we know it's in the second group, which is why it's a +2 charge. And then here's our polyatomic ion. Having sulfur and 4 oxygens together with a charge of -2 is called sulfate. Therefore, this compound is calcium sulfate. We would not give this compound 3 names because it has 3 elements in there. The calcium, sulfur, and oxygen, we would not name this calcium sulfur tetraoxide. Compounds have a first name and a last name, and so you will have a cheat sheet that tells you that SO4 with a -2 charge is sulfate. Therefore, calcium sulfate. Now remember when we said that when we make these compounds that they have the lowest ratio. Notice that calcium has a +2 charge and sulfate has a -2 charge. If I look at this compound, right off the bat, I notice that a +2 and a -2 is already neutral. So we do not need any subscripts. However, if you like that crisscross method that I showed you, and you want to put this 2 here, and this 2 over here, we have to put the SO4 in parentheses and then put a 2. Notice that I have a 2 and a 2. And we can reduce that to a 1 and a 1. So we would write that as just Ca and then SO4, calcium sulfate. If you ever see a compound that has more than 2 elements, somebody is in a polyatomic ion. Here's another one. Here's 2 polyatomic ions. This is fertilizer. Ammonium, notice I have NH4 and together is a +1. And then I have NO3 with a -1 charge, that's nitrate. So this compound is ammonium nitrate. In this section, you are going to be able to write the name and formula for an ionic compound containing a polyatomic ion. Like this plaster cast and the fertilizer that we just looked at, lots of products contain polyatomic ions, which again are groups of atoms that have an ionic charge. A polyatomic ion is a group of covalently bonded atoms. That means that they are nonmetals and they have an overall ionic charge. So therefore, if we were to look at these, nitrogen and hydrogen are both nonmetals. Nitrogen and oxygen are both nonmetals. So they are covalently bonded, but they have a charge. So we have ammonium, it has a +1 charge. Nitrate, carbonate. This guy, HCO3- can be called hydrogen carbonate or bicarbonate. Either one is fine. OH is hydroxide, nitrite, phosphate. These are some common ones that we'll be dealing with. The names of common polyatomic ions, there are some that end in ate, like nitrate and phosphate. If there is 1 less oxygen, then the name turns to ite. Notice that we have NO3, so that's nitrate. NO2 is nitrite. Notice the difference here between PO4 and PO3. This one has 1 less oxygen, so it went from ate to ite. HCO3 with a -1 is called hydrogen carbonate or bicarbonate. And same with this guy, HSO3 with a -1 charge is hydrogen sulfite or bisulfite. Here are some names and formulas of some common polyatomic ions. And you, again, will have these as a resource for any quiz and test, but it is important that you recognize that it is a polyatomic ion, and then you can search for what its name is. So we have hydroxide, we have ammonium, NH4, again, the nitrogen is in this, NO3, NO2, so nitrate, nitrite. Polyatomic ions that have chlorine in it, we have perchlorate, chlorate, chlorite, and hypochlorite. And again, you just would need to recognize in a compound, for example, if I had sodium perchlorate, sodium chlorate, sodium chlorite, sodium hypochlorite, you need to just be able to say, oh, ClO4, ClO3, ClO2, or ClO. You just have to pick that out from wherever it's written. Carbon-containing ones, we've got carbonate, bicarbonate, cyanide, or acetate. Ones that contain sulfur, we've got sulfate, bisulfate, sulfite, and bisulfite. And phosphorus-containing ones, we've got phosphate, hydrogen phosphate, dihydrogen phosphate, and phosphite. When we're looking at an example of a formula, like magnesium nitrate, we need to identify the cation and the polyatomic ion, which is our anion. In this case, the anion we know is a negative charge, so our polyatomic ion, NO3, we would go back and look at our cheat sheet. See, the NO3 is a -1, is nitrate. And magnesium, we know on our periodic table, is in the second group, so it has a +2 charge. When we go to write this formula, it is important to note that magnesium has a +2 charge and NO3 has a -1 charge. That is not a neutral compound. We need 2 NO3s. 1, 2, that would give us a -2 charge there, and we have 1 +2, so a +2 and a -2 would give us an overall charge of 0. So in order to have 2 nitrates, we have to put parentheses around the NO3 and say that there's 2 of them. If we didn't, it would look like this, NO3, 2, and it looks like we would have 32 O's, which is not the case. We need to say that we have 2 NO3s. So the subscript is outside of the parentheses. When we're naming ionic compounds that contain polyatomic ions, we write the name of the positive ion, which is usually a metal, first, and then we write the name of the polyatomic ion last. So it's first name, last name. This is sodium sulfate, Na2SO4. The reason why that 2 is there is because the sulfate has a -2 charge and the sodium has a +1 charge. So that would mean that I have 2 NAs and 1 SO4. Iron 3 phosphate. That means that my iron has a +3 charge. And if I looked back at my cheat sheet here, phosphate right here has a -3 charge. A +3 and a -3 gives me an overall neutral compound. So there's 1 iron and 1 phosphate. Aluminum carbonate. If I looked at my periodic table, aluminum has a +3 charge and carbonate has a -2 charge, which is why there's 2 aluminums and 3 carbonates. We still have to balance that and make it have a net 0. Here are a bunch of ionic compounds that contain polyatomic ions. We have aluminum phosphate, aluminum sulfate, barium sulfate, calcium carbonate, calcium phosphate, chromium 3 sulfate, magnesium sulfate, potassium carbonate, silver nitrate, sodium carbonate, sodium hydrogen carbonate or sodium bicarbonate, and zinc phosphate. And take a minute to see all of these medical uses for all of those polyatomic ions. Why don't you pause the video here and try to name these 2 ionic compounds. Now the first one should be copper nitrate. And we do need to specify what copper's charge is. So if I have CuNO3, 2, we do need to go back and find nitrate on our cheat sheet here. Nitrate, NO3, has a -1 charge. So if we know this is -1, that's why there's 1 copper. So this 2 must be copper's charge, which is why it's copper 2 nitrate. And then we have KClO3. So we know K is potassium. We need to figure out what ClO3 is. So we go back to our cheat sheet. ClO3 is chlorate. So we have potassium chlorate for that second compound. Here's a little summary of ionic compounds. An ionic compound is a metal and a nonmetal. If it's a metal, or if it's a polyatomic ion and it's ammonium, NH4 plus is the only polyatomic ion that's a cation, that's positive. Forms only one positive ion or forms more than one positive ion. See where this goes. We just use the name of it. Versus, this would be for transition elements where we need to use the Roman numerals if it forms more than one positive ion. And then we have our nonmetal, the anion. It's either just chlorine or just oxide or just phosphide, or it's a polyatomic ion. If it's a monatomic ion, we end in "ide." If it's a polyatomic ion, we just use the name that's on our cheat sheet. Take a minute to look over the review for this section and make sure that you understand the learning goals.